Hey everyone, welcome back. In a previous section, we explored the foundation of smart contracts, what they are and how they work. We went through the complete smart contract lifecycle diagram. In this section, we are going to see in practice the smart contract lifecycle from initialization to deployment and interaction. However, we won't be diving into testing today. That's going to be our focus in the upcoming section, where we'll explore comprehensive testing strategies for your smart contracts. You'll see how easy it's to build, deploy, and interact with smart contracts. Remember from our earlier discussions that Algorand supports multiple high level programming languages for smart contract development. You can write smart contracts in both Algorand Python and Algorand Typescript. Today, we are focusing exclusively on Algorand Typescript, and in our next section, we'll cover the same life cycle using Algorand Python. Now, you might be wondering why TypeScript? Well, if you're coming from a web development background, TypeScript will feel very familiar. It provides excellent type safety, great tooling support, and integrates beautifully with the broader JavaScript ecosystem. By the end of this video, you will have the resources to set up your development environment with Algokit. You will be able to initialize a TypeScript smart contract project. You will be able to understand the project structure and workspace concept. You will be able to write and understand basic smart contracts. You'll also be able to build, deploy, and compile your smart contracts. And also, you'll be able to interact with your deployed contract using Lora. So, open up your code editor and let's dive into building your first Algorand TypeScript smart contract. Now, before we start writing any code, let's make sure you have everything set up correctly. I'm going to walk you through the official prerequisites from Algorand developer documentation. Note, I would not show you how to install it, but by following this guide, you should be able to install all the prerequisites in your operating system. So, first of all, we will have to install Algokit. Algokit is Algorand's official development toolkit. Algokit handles most of the complexity for you, but there are a few essential tools we will need. It provides everything you need to initialize projects, build contracts, manage local networks, and deploy applications. The installation process may vary depending on your operating system. So, for example, for Mac OS, you can use Homebrew. On Windows, you can use Chocolatey. For Linux users, we have a lot of options, including package managers or direct installation. Okay, let's verify everything is working correctly by going to a terminal and typing in Algokit version. As of this recording, the latest version is 2.7.1. If you're watching this video later, you might see a newer version, so you can check out the latest version at the time or upgrade if you have an older version, and you'll be good to go. The next crucial component is Docker. You might be wondering why we need Docker for smart contract development. The answer lies in Algorand's LocalNet. LocalNet is a complete Algorand blockchain that runs locally on your machine. It's identical to public Algorand networks, but it runs in isolation. This means you can develop, test, and experiment without spending real algos or waiting for block confirmations on public network. So Docker allows us to run this local net in a containerized environment, ensuring consistency across different development machines and operating systems. You can start localnet through Algokit using Algokit localnet start, and this would spin up multiple Docker containers that simulate complete Algorand network. So make sure you have Docker desktop installed and running. You can download it from docker.com, and once installed, you should see the Docker icon in your system tray or menu bar. And if your localnet is up, you can see these images in your Docker as well. Now, for the exciting part, let's initialize our first Algorand TypeScript smart contract project. So let's run Algokit init. This starts an interactive session where Algokit asks you about the type of project you want to create. Let me walk you through each option. So the first question is regarding project template. So we have few options like smart contract template, which is for smart contract development only. Then there is an option of full stack template, which includes both smart contract and frontend. And then we have another option, which is a custom template, which you can customize according to your needs. For this video, we'll select the smart contract template since we are focusing on the contract lifecycle. The second question that comes up is which language would we want to use for our smart contract? So we have two options of Algorand Python and Algorand TypeScript. Here's where we choose TypeScript. Remember that we are covering TypeScript for this section. Now, the third question is the name of the project or the directory we want to create the project in. I will name this as TypeScript Hello World. You can choose any name you prefer. The next question is regarding the contract name. We will keep the default Hello World for our first contract. So this will be the name of our smart contract class. So next we can choose from different presets. So we have first a starter template, which is the basic template with minimal setup. It is designed for quickly implementing and testing features. Then we have production preset. This preset is intended for production-ready applications. It includes more advanced features such as unit tests, CI automation, and other best practices to support robust, maintainable projects. And then we have custom, which lets you customize the template components like features and configurations. For learning purpose, I recommend product as it includes helpful tooling and follows best practices. Next, we have the deployment language. Next, we have if you want to run Algokit Project Bootstrap. This asks if you want to run Algokit Project Bootstrap to install all dependencies. I'll select yes because it saves us time. Now it might take a minute or two depending on your internet connection. So now the final question is regarding Git repository. If we want to initialize a Git repository, I'll say yes to initializing because version control is always a good practice. Perfect. Algokit has now created our project structure and has installed all dependencies. Algokit has automatically opened our project in VS Code or Cursor, whichever IDE you are working with. And now you'll notice that it has opened in something called as workspace mode. This might look a bit different from what you're used to. So let me explain why this is important and how it works. When you look at the file explorer, you might notice the structure looks a bit different. Here we have a root directory, and inside that there's a projects folder containing our actual smart contract project. This is what we call the Algokit workspace structure. So workspace mode is a feature that allows you to work with multiple related projects in single IDE instance. It helps you in managing multiple related projects under a single root directory, making it ideal for complex applications that consist of several sub-projects such as smart contracts and front-end applications. You can easily switch between your smart contract code and your front-end code without losing context, and you can share certain configurations and resources. At the root level, we have a .vs Code folder with workspace settings. There is another algokit.toml file with workspace configuration. Now here you'll find the project name that you entered, and this is where we will do most of our work. So one of the nice features of workspace mode is that you get dedicated terminal for each project. VS Code automatically sets up the correct working directory and environment for each project. Now the workspace behavior is controlled by .code workspace file. This file tells VS Code how to treat the different projects and what settings to apply. But if you want to run multiple sub-projects, example different smart contracts, you can run Algokit init from the workspace root. You can follow the same steps that we saw earlier, and now you will have the sub-project added to your workspace. Now we'll open up our terminal, and we can use Algokit project list command to get the list of projects in this workspace. Now, if workspace mode feels overwhelming, or if you prefer working with individual projects, you can absolutely do that. So workspace mode is recommended for most projects, especially if you anticipate needing to manage more than one component or you want a scalable, organized approach to development on Algorand. For the rest of this video, I'll continue using workspace mode, but remember that everything we do will work exactly the same way if you prefer having a single project or multiple projects. Now let's dive into our generated project and understand what Algokit has created for us. At first glance, there are quite a few files here, but don't worry, most of these are configuration files that you won't need to modify regularly. In this section, you will notice a smart contracts folder. Inside this is Hello World, which is where your smart contract code resides, along with integration tests, unit tests, deployment scripts, along with integration tests, unit tests, and deployment scripts. Inside the smart contract folder, there's another folder called artifacts. This folder doesn't exist yet. It's created when you run build command. During the build process, Algokit compiles your smart contracts and generates several important output files, which are stored in the artifacts directory. Although you can't see it right now, once we successfully build the contract later, the artifacts folder and its contents will become visible. Everything else is just either configuration and tooling to make your development experience smooth. Let's start by exploring your Hello World contract. Now, this is our smart contract file. Apart from this, we have three more files. So, one is contract.spec.ts. This is the file that you will use for writing unit tests, and contract.endtoend.ts. This is the file to write end-to-end tests, or which you call as client tests. Both of these files will be covered in the next section when we'll write tests for our smart contracts. There is also deploy config file. This is a script that Algokit uses to deploy smart contract to Algorand. And then optionally, you can also call a method on that contract. Now, coming back to contract.algo.ts file, this is a fully functional Algorand smart contract written in Typescript. Let's break down what's happening over here. The first line imports the contract base class from Algorand Typescript. The contract class is used to define Arc4 compatible smart contracts in Typescript. Now the next line, which exports class Hello World, this declares a new smart contract class called as Hello World that extends the contract base class. By extending contract, any public methods in this class become ABI methods, which will be called from off-chain clients or other contracts. Now, inside this class, we have a function, which is a public method named as hello, which takes a string named name as an argument, and it returns a greeting string. Because it is public, it is exposed as an ABI method, and that can be called externally. Now that we understand our contract structure, let's build it. The build process is where Algokit compiles your smart contract and generates the necessary artifacts required for testing and deployment. In your terminal, run Algokit project run build. If you have multiple projects, you can build with a -p and the project name, for example, Hello World. Then it will only compile the project that you have specified. If there are any errors in your code, the build process would stop and show exactly what needs to be fixed. Perfect. You should see output indicating that the build was successful. Let's examine what happened and what artifacts are generated. Now, inside this artifacts folder, you will see several important files. First, we have tail files, which are approval.tail and clear.tail. So, hello world.approval.tail file contains the approval program. This is where the main logic of the smart contract is executed on application calls. Also, there is a hello world clear.tail. This is the clear state program, which handles the logic when a user clears their local state for the application. So these both are tail assembly code. This is quite different from our TypeScript code. This low-level code is what actually runs on the Algorand virtual machine. You can see instructions like push in and push bytes transaction A, etc. So these are the basic building blocks of tail programs. Now we also have Puya map files, both for approval and for clear. So these are the source map files generated by the Puya compiler. They map the compiled tail code block to the original high-level source code, aiding in debugging and tracing AVM Debugger, which is a tool to debug your smart contracts. For this section, we won't be covering AVM Debugger. Apart from this, we also have an arc32.json, which also provides a comprehensive application specification, including methods, state schema, and other metadata. Now, arc32 is being superseded by arc56 file, but both serve a similar purpose to fully describe a smart contract for use by clients and by tooling. Now here we have an arc56.json as well, and this is your contract's API specification, and this extends arc4 and arc32 by adding even more metadata and descriptive fields, making it easier for clients to interact with contracts and for tools to generate type-safe clients. Now, arc56, as we mentioned earlier, is intended to eventually replace arc32 as the standard for application specification file. We also have one more file, which is hello world client.ts file. This is a TypeScript client tailored for your smart contracts, and this provides type-safe methods for contract interaction. This client is generated from the ABI, and this file simplifies deployment and invocation of contract methods from TypeScript code. Now that we have successfully built our contract, Let's examine how deployment works. Remember the deploy config file. This file defines how and where your contract gets deployed. The deployment script imports two key components. First is the Algorand client. This helps to connect with the Algorand blockchain. It handles transactions, queries, and network communication. Then the second one is Hello World Factory, which is an auto-generated client to interact with Hello World smart contract. Let's break down each and every step. When we use Algorand client.from environment, this creates an Algorand client using environment configuration. The client automatically detects which network to connect to based on your environment variables, or it defaults to localnet. We load the deployer account from the environment. If we scroll over here to client.getTyped app factory, here we create a typed application client specifically for our Hello World contract. The default sender ensures all transactions are sent from the deployer account. Now, coming over here to factory.deploy, this deploy method handles the complexity of smart contract deployment. The options specify on update append, which ensures smooth updates, and on schema break append, which allows save schema changes. Now, if your app was just created, then we will fund it with one algo. Now, if your app was just created, we will fund the app with one algo over here. And then once we have done that, finally, we can call the hello method from our contract with the argument world. In the end, we will also log and print. In the end, we will print the response to the console. Once we have gone through the deployment script, we would want to deploy it. But before deploying, let's ensure that we have already started our localnet. So if you haven't done that, first, let's make sure the Docker is running, and then we will execute Algokit localnet start command. You should see output indicating that localnet containers are starting. Now, this process creates several Docker containers that work together to simulate a complete Algorand network. Now, if you want to check whether your localnet has actually started or not, you can also use Algokit to verify that your localnet is working smoothly. Let's use Algokit localnet status, and this command shows you the health of all localnet components. You should see running status for all services. If any service shows an error, you will need to troubleshoot before proceeding. The Algokit localnet reset command is particularly useful when you want to start with a clean blockchain state. Now, localnet comes pre-configured with several test accounts, each loaded with test algos. Algokit automatically manages these accounts for you. When you deploy contracts, it uses these accounts as needed, which handles all the complexity behind the scenes. We have built our contract, we have understood the deployment configuration, and set up our localnet. Let's bring it all together. Let's deploy our contract to localnet. For that, we will use Algokit project deploy localnet. Here, if you have any other network, you can specify that instead of localnet. In case you have multiple projects, you can also specify with -p and the project name like Hello World, and this would do the same thing for you. Okay, perfect. So let's analyze what happened during the deployment. Now you should see output similar to this. Let me explain each part of this output. First, we have an app ID, which is 1002, which is the unique identifier for your smart contract on the blockchain. Now, this number is how applications and users will reference your contract. The app address is the actual blockchain address for your smart contract. This address can hold algos and other assets, just like a regular account. We have discussed about this in the previous section. The deployment script automatically called our hello method with the parameter world and received the response hello world. This proves that the contract is deployed successfully and our logic is working correctly. Now, after successful deployment, you would want to record your app ID and save it for future interactions. Now that we have successfully deployed a smart contract, let's now visualize and try out Hello method on Lora. So Lora is a visual blockchain explorer that makes it incredibly easy to interact and debug our smart contracts. To open Lora, we simply run Algokit localnet explore, and this will open Lora in your default web browser. With Lora, you can do multiple things. For example, you can check out latest blocks, latest transactions, and you can also add new transactions and build transactions here. And you can also fund your existing localnet account or any other testnet account. For this section, we are going to interact with our smart contract that we have recently deployed. For this, You can either deploy a new app using deploy new, wherein you will have to upload your arc56.json, or you can also use an existing application ID. Remember the application ID that we saved after deploying? Here, we can upload our arc56.json file, that artifacts folder generated. Now, once we select that and we click on next, we can select the name of our application that we want to keep. Let's keep it to Hello World 1.0. Now, if we click on this application ID, we see a lot of contract details over here. With the API methods that we had in our contract, which is hello, we will be able to see different details. For example, the creator address, the account address of this application, the application name, ID, and other details. Also, if we scroll down over here, we can see all the transactions that have happened on this contract, and we can also see different states. We covered global box state in our previous section. If we click on call method to execute it, we see a list of details over here with an option to add our argument. So let's enter Lora user over here. And now when we click on add, it will add the detail over here. It is generally a good practice to populate your resources here, since there are no accounts assets that need to be added over here. It won't populate these resources. When you click on send button, it will ask you to sign it. Once we have done that, we can see that the transaction has went through. We can also visualize the transaction that the application call has been made using this transaction ID with the method name and the return value. Now, if we click on this transaction, we can see the details of who is the sender and which application ID has done that. Congratulations, you have just completed the life cycle of Algorand Typescript smart contract development and deployment. Now let's recap what we have accomplished together in this video. We saw how to install Algokit and all other prerequisites required. Then we created a complete TypeScript smart contract project. We explored the Hello World contract. We compiled it to Teal and generated artifacts. We successfully deployed it to localnet, and we used Lora to interact with our deployed contract. Now that you understand the basics, you can explore more complex smart contracts. For example, you can try out counter contract, voting system, or token creator as beginner-friendly projects. You can also try out decentralized exchange, NFT marketplace, or governance-based systems for intermediate projects. And for more advanced projects, you can go ahead and try out cross-chain bridges, DeFi protocols, and DAOs. Thank you for joining me on this journey through Algorand TypeScript smart contract development. I hope you found this valuable and that you are excited to continue building on Algorand. Now, once you feel you have a grasp of it, I would highly recommend you, and this is completely optional and up to you, to modify the Hello World smart contract with your own methods. Try deploying your modified contract and use Lora to test different scenarios. All the links and resources mentioned in this video are in the description below. Don't forget to join the Discord community where you can ask questions, share your projects, your experience, and connect with other Algorand developers. So keep building, keep learning, and in the next section, we will see all of this written in Algorand Python. Until next time, happy coding.